Hello and welcome to TidyX episode 7, where we're going to be exploring GDPR and faceting. All right, so my name is Ellis Hughes. I'm a statistical programmer at Fred Hutch Cancer Research Center. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward, and I do data analysis in sport. You can find me on Twitter at OSPPatrick. And if you have questions for us, as far as maybe some of the things that you've seen us go over, things you want clarification on, or perhaps you find some interesting code on the internet that you'd like help explaining, you can hit us up with questions or comments at tidy.explained@gmail.com.
All right, so this week's Tidy Tuesday data is GDPR fine. So it comes from Bob Rudis. So we've talked about him before. His Twitter handle is HarborMaster, so HRBRMSTR. And so he's interested in, data privacy and whatnot. So GDPR is a general data protections regulations in the EU, so European Union, and it's about, protecting our data. So making sure that people aren't doing things with data collected on us that we don't want them to be doing. So, generally a good thing, it seems like.
That'd be great if Bob Rudis actually scraped data from the company that's supposed to be protecting the data.
Well, I think it's actually freely available, so that
this
so
is freely available data.
Yeah. All right, so there were some pretty great images and plots that we saw this week, but one that we thought that y'all might be interested in comes from Danielle Barnas, where she does a heat map of the various fines over the 2018, 2019, and 2020. And then she goes and looks at, does a heat map of what the fines are and breaks it up by month and by year. And then breaks it down even further by week of the month. So you can kind of see how it trends over time. 2019, it looks like there were a number of fines levied against some companies. So that's interesting to see. It was so active in 2019. Though, I mean, I don't know how long it was in existence in 2018. Definitely not an expert on this. But we reached out to Danielle because we thought that y'all might be interested in this, and she sent us the link to her code. So it's on GitHub. So we took this and we brought it into our R session. So we got that over here. And now we're going to go through and start explaining it. So right off the bat, you can see that she is putting a lot of comments in her code. Just, briefly looking at this. So it's going to be really easy to go through and explain all of this for y'all. So first step is she does this rm list equals ls. I think we've covered this before, but what this will do is it'll list all the objects that are in your current environment and get rid of them for you. So it'll delete that. So this is a common practice you'll see in a lot of scripts, but it's not best practice because it doesn't actually remove any objects that you've attached into your namespace via the attach function. It also won't unattach or unload any packages you've installed. So if you'd already loaded all these libraries before, it's not going to get rid of them for you. So you're not working in a truly clean environment. Really, the best way to do this if you talk to Jenny Bryan, is if she sees this in your R script, she's going to set your computer on fire. And the way to avoid that is to always, whenever you're going to be running a new R script, restart your R session. And so you can do that by using the restart R here in R Studio, and they have a shortcut Control-Shift F10. And so that'll completely wipe out your R session and do that and clear it all out for you. So she's loading in the tidyverse. She's got her libraries at the very top here. ggplot2 is actually part of tidyverse, so you don't need to load that explicitly. Lubridate, which is a package for handling date objects, which can get a little hairy and unwieldy if you're not used to them, but that's also brought in by tidyverse, so we actually don't need these two explicitly loaded at this point in time. Plyr, which is the predecessor to dplyr, it's also loaded in tidyverse, but I feel like there's an actual reason why I should be bringing this in separately. So if you're intentionally doing it, that's okay. Then Scales, which is a library from rlib that has a lot of utility functions on, scaling various, like adding commas to large numbers and whatnot. So it has a lot of really useful functions in there. And then library Zoo, and I believe that's for handling time series data
Yeah.
as well.
Yeah. Zoo will help you with time series data and rolling metric, like rolling addition, rolling sum, rolling average, things like that.
Gotcha.
One thing with loading Plyr and the Tidyverse suite there is you just have to be careful because sometimes Plyr and dplyr will have functions that kind of can cancel each other out. We've talked about this in previous TidyX screencasts about using potentially the conflicted package to try and specify upfront what it is that which package you want to prefer functions from. One of the things that you could do is just not load Plyr, and then if you were going to use it for something explicit later on in your code, you could just type Plyr and then 2 colons and then write the function, and it'll call directly from that. Yeah, exactly. Something like that.
Yeah, without the spaces, of course. All right, so next she loads in her data. She's doing this using the long URL that exists. You can also do this using the Tidy Tuesday R package, which is available on GitHub. I wrote it, so I'm a little bit biased on that. All right, so now we get into the actual data processing that she does. So here she's using the GDPR violations data set, and she's converting it. So it looks like originally it was brought in as a character. Let's actually run this so I don't just talk at you. All right, we loaded in the data set. There we go. Date, it looks like it was actually brought in as a character vector there. And so if she wants to be treating it as if it is a date object, she needs to convert it into a date object. So sometimes readtsv will handle that for you and be able to detect it. In this case, it wasn't able to do that. So she's using this parse date function that exists, I believe, in Lubridate. Let's double check that. Oh, I guess it's not. It must be in readr.
Yeah, readr is where it came from.
Yeah. So what she's doing is she's specifying the format. So this is the format of the character vector date. So she's saying, so %m says first you're going to have the month numeric value, so 1 to up to 12. Then there's going to be a slash, / then %d says, okay, now you're going to have the day of the month that exists. And so this will be a number from 0 up to 31. Next, there is the %y, and it's capitalized. So this tells it that, okay, you're going to now have a slash and then the 4 numeric year, or 4 number year. So you can also sometimes see it where they only list the last 2 numbers of the year, so like 92 for 1992, for example. But in this case, it looks like, let's do a quick peek at this vector here. Yeah, so they've got the 4 year number there, so they'll actually did that. Next, she's specifying, okay, any cases that are NA, define it as a character. And so this is, I'm assuming, for later on her processing, so it doesn't trip any warnings that way. Locale, so that's telling it to use the default locale. So locale is the timing that exists, I believe. And then trim white space, so this will remove any extra white spaces that exist in this character vector there. So if, like, say if there's a space in front of this right here, so it was shaped more like that, it would still be able to see it like it was written like that. Here, let's zoom in a little bit just to make this a little clearer for y'all. All right, so she does that. So let's run all that. Hey, no warnings, awesome. All right, so now she's doing actually a lot of munging here with the dates, which is where Lubridate really comes in handy. So she's taking GDPR violations that she's edited, extracting the year and converting it into a numeric value, extracting the week of the year and turning it into a numeric value, getting which month of the year as a character value. So this will be the month name, so like April, February, because before, they were like 03, which is March. Now it'll be coming up as March. Now she extracts the weekday using the weekdays function from the date. The extract the year and month as a numeric. So interesting. I haven't seen that done before. And then she converts it into a factor. And then she uses this. So all of these steps here she does in separate mutate functions, but what she also could have done is just done a bunch of commas here and formatted it that way. It's not right or wrong. It's just different ways to think about it. So if she wanted to think about all these processes happening, all these mutations happening at once, you can do a comma, but she chose to do it with a bunch of mutates there, and that's perfectly fine. Oh, went too far. All right, so now she's made all those changes there and throws it into a ddply. I've never actually used a ddply before. Have you, Patrick?
I have, when I used to use the plier package more. So this would be one of the instances where, for example, if you didn't explicitly load plier, you could type plier ddply and then your work there. It's been a long time since I've used the function, though. Usually you'd pass it your data frame and then the column that you want. So she's got it right there is year, month. That is which column is that? That's the parse year, month to a factor. Okay. So transform month, week equals 1 plus week minus 1 week.
So it's looking like this is like a precursor to like a group by. So it's saying for each value, each unique value in year, month, F, perform a transformation where find the... So this is getting what week in that month is it?
Yes.
Yeah.
And that's how ddply works. So it's usually if you were using it by itself, you'd pass it the data frame, then the variable that you want to group by, and then how you want it. So for example, just the same functions that work in dplyr. For example, you could put if you put mutate, it would add the new column of the group by data right onto your data frame. If you did it by summarize, it would create a new data frame with the summary statistic of interest based on your group by. So you pass it you pass it that function where you want the data to go, and then you actually pass it the function or whatever type of mathematical derivation of the data that you're looking for. Yeah.
Okay.
So she creates a new column called month week.
Yeah, exactly.
Which is 1 plus week minus the minimum of week.
Yeah, so this will give us weeks 1 through 5 basically for each month.
Yeah.
Sorry about that. All right, so now we're going to run that. All right, so now we've got the new data set there, and so you can see on that far right column, month, week, 1, 1, 1, 1, 4. All right, so it's not in any particular order. All right, so then she takes this data set and divides by 1,000, so she's getting the price by 1,000 euros, just for a simpler figure, make it simpler for understanding what's going on there. Otherwise, the values can get pretty large. Yeah. Next, she's going to subset or filter to keep only the cases where the year is greater than or equal to 2018. So that's, as we saw in the plot originally. So only years 2018 and newer were kept. Additionally, cases where the actual fine got paid. So I'm guessing there were cases where price div was less than 0, so they didn't pay it, or something like that. So that's interesting to find that, or they were paid back. But then she throws it into a select where she's now subsetting to only keep the values that she actually cares about for plotting. So she cares only about the year, what month it is, which month week it is, the month day, so is it a Wednesday, a Tuesday, and what they paid. So subsetting there. Let's take a quick head of this data set here. So yeah, as you can see, year, what month it is, the week of the month, the weekday, and then what they actually ended up paying. All right, so now she's throwing it into the plot. So this is a plot that we saw there. So she takes GDPR violations and uses the aesthetics. So she didn't label them, but it's done in the order So this is the x-axis, which is month week. So which week is it? Month day is, is it a Monday, Tuesday, Wednesday? And then the fill. So this is particular to the geom that she ends up using down here. So this might be better used dropping it into the geom tile function that she uses down here, because fill doesn't exist for all geoms, right? So this might then start appearing in cases that you didn't geoms you don't expect it to, or coloring it in ways you don't expect it to because of that. So then geom tile is a way to do heat maps. So it's going to draw a little square based on your X and Y, the coordinate. It's going to draw that square there, and it's going to color it or fill it based on the fill aesthetic here, which is the price.div. And then otherwise color equals white. So that's going to set the background color of the tiles there. So then she uses Facet Grid. We haven't actually covered Facet Grid before, but it's a really, really powerful tool. So what Facet Grid can do is you're then telling it, okay, basing it off of whatever we drop in here, subset my data and only plot those in smaller facets. So facets are like the mini plots that exist across your data set here. Mm-hmm. So we can let's show it first without facet gridding. So here you go. We get month and week, but not a whole bunch of information can be drawn from here, except that the first Saturday you get pretty hammered compared to the other ones. It's a lot higher there. So interesting. But now if you add this Facet Grid, we're going to add this next level of detail where it's going to have the year and the month included with that. So, all right. So this is now the format of the plot. Give my computer a second to visualize that for us. All right. So as you can see, now we have the information where we can see which month it is and then which year we're plotting in. So once again, 2019, pretty hot year for fines coming out there. In 2020, we're still pretty early on in the data, but March, January, February, it doesn't look as heavy as 2019, but people are getting fined. It's interesting.
Did she not? I wonder. I can't recall from her original post, or maybe eventually in the code she does this. Does she order the months by the? You see how the month order across the top of your x-axis is not in order.
Yeah. So what happened there is they're
would have been alphabetical. Yeah.
Yeah, they're factors, so they're treated alphabetically. And the same thing you can see for the weekday.
Yeah.
So maybe a way.
Does she do it in the code later? I can't remember on her original post if it was actually in order or not.
No.
Okay.
So one thing to consider
to
consider in the future would be to add that extra bit of information where you're actually defining the order in which they should be appearing.
Yeah.
But it's still interesting to view there. Then she's adding all her labels, like week of the month there for the x-axis. She adds her title and subtitles and defining what the fill is. So this will then update the legend, I believe. And then she's immediately throwing it into a GG save to save it. And then this is good practice. So you can tell by the way that she did that. And you can also look at her repository. Let's quickly bring that up. Where she is using, it looks like she's using like an R project or whatnot, because she's referencing this top level here, this data folder, week 17, where she's got it saved, and that's the path that she's using there. And so if I were to have copied down her entire repository, I could run this immediately, but since I didn't, I can't, so I won't worry about saving it. But let's look at the final plot. Oh, we didn't cover this scale fill gradient. So what this is going to do is it's going to update the fill. So I think in our last plot, you were seeing how it was using this blue scaling, which, I mean, my favorite color is blue, so I'm okay with that, but it doesn't really let you see the clear differences between anything. It's also a linear scale, which, when you have financial data like this, it's Patrick, what were you calling it earlier?
Oh, yeah, financial data like this, you tend to have really long right tails. For example, if we were to, think about the yearly income of maybe like American workers, you'd have everybody, and then all the way to the right, you might have, Bill Gates and Jeff Bezos and Warren Buffett and people like that. So the log scale just helps to constrain some of those outliers and put the data on a bit more of a normal. Yeah. So now if you were to do a hist of the log of, and that, and we get a bit more of a normal, bit more normal distribution on a log scale. Right?
Mm-hmm. And that just makes it, more visually, you're able to kind of pick out some of the differences a little bit better in that mid-range there.
It does change some of the properties. Like if you were analyzing it, it would change some of the ways that you interpret the outcomes and things like that. But it's easier, when you talk about financial data, a lot of times to work on a log scale, just because there can be such large outlying values, particularly towards the right, where there's people that, or countries, for example, that make or produce a substantially larger amount of money than the others.
All right. Well, thank you so much, Danielle, for allowing us to explain your code. I found this valuable to see, some plier code that I've never seen, and hopefully everyone else finds this valuable. So now we're going to apply using Heatmaps and faceting on a new data set. So we're going to go back to a data set that we've used in the past. It's going to be the NBA statistics that we're using. So, Patrick, do you want to take us through that?
Yeah, this is a fun one. I use Facet wraps a lot and Facet Grid a lot in my everyday work, because a lot of times you're trying to break things up, maybe as we'll show, by position group or by season or by team, so that you can look across different levels of your data. So we start out loading our packages, a lot of similar packages that Danielle had. Tidyverse, obviously, we use Reshape 2 here. We'll show why in a second. RVest is how we're going to scrape the data. The conflicted package is what we talked about at the start of this, and we've talked about it in previous TidyXs, where we're basically saying we prefer the pluck function from the per package, and we prefer the filter function from the dplyr package. And that is one that I have gotten in a lot of trouble sometimes. If I've worked with like students before, they might load the plyr package and the dplyr package, and all of a sudden filter starts kicking out all these errors in their code. And we spend like 20 minutes, and I'm like, why is this happening? Only to then find out that they've loaded the plyr package, and I'm like, oh yeah, this is a problem. And then the other thing I do is I just, from the outset, I created obviously our theme set. We prefer theme BW or theme light over the standard kind of gray scale from ggplot. And then I specify a custom function right there, which is just going to help us z-score our data. So standardize each variable by subtracting that variable from the mean of that variable and then dividing by the standard deviation. Mm-hmm. So we've done this before, so there's no need to really go through a ton in terms of how we got the data in. We get the URL of basketball reference data from 2019. This is the season totals for each player. We pull that URL into a table. We want to pluck the first table within that URL. And then I'm filtering out the rank column, which is just a column that's all the way to the left of the data frame that kind of ranks the players. It's unnecessary for our purposes.
It exists because it was a HTML table just to help you as you were scrolling through it. It has no value for us, though.
Correct, yeah. Okay, so when you pull this data in, you'll find that there's a whole bunch of columns that are pulled in as characters, so I just make sure to specify what those columns are, and then this little function here, this little apply function here from baseR is what I use to say anytime you find a character value within those columns, just turn it into a numeric for me.
Yeah, we covered this in more detail in episode 3.
Yep. Some of the players have played for multiple teams, maybe been cut and then re-signed or traded. So I just do a quick group by of those players to put all of their data at a seasonal level based on their position group. And I retained age. I don't know why I retained age. I didn't need it for this, but
I felt like you needed it.
Did I? Yeah, maybe I did. Maybe I wasn't sure. Maybe I wasn't sure of exactly what I wanted to facet. I guess we could have done different facets, but
yeah.
Okay, so I then get these stats that I want for the heat map. So I basically take that NBA main data frame that I created. I use a little ungroup here the structure of the data was based on that group by above. So I had to kind of I had to back out of that in order for the select function to work and the mutate function to work. I select the columns I want. And I do a little bit of renaming in there just to get the percentage signs out of the field goal and the 3-point percentage and just be a little more explicit with those things. And then for the position group, there's instances where there's like one time that a player is called a center dash power forward or a small forward dash small shooting guard. I think those instances happen like anywhere from 1 to 5 times. So all I did there was basically just say if you see center or center dash power forward, just make them a center. And if you see power forward dash center or power forward dash small forward, make them a power forward. So I went through and did that. And then the true at the bottom basically just says, because if you run a case when, if we had deleted that true tilde position and we had ran our data here, we'd get a whole bunch of NAs anywhere that R doesn't see the case when. So
as you can see, there's very few.
Yeah, exactly.
It's because
so there's all the NAs.
Yeah, all of them.
So the way around that is to pass this argument of true tilde position, and so that'll just retain anytime it sees a case that isn't one of those case whens. It just passes the original position to it. It's the same as in if-else statements. This would just be like the else statement. If none of those if none of those 4 conditions are met, else just deposit the original position into the data. Then I group by position, and this is where I do a mutate at. So I'm saying at all of the variables from field goal percentage to turnover, apply my z-score function. So now I'm basically within their position groups. This isn't, if I remove the group by, I would be doing the z-score across the entire population mean and the entire population standard deviation. But here I want to look at the players within the position group that they play. So I group by, and then now I'm passing. So it's going to find, let's say, a point guard, and it's going to say find the mean for point guards and the standard deviation for point guards and calculate this point guard's observed field goal percentage, for example. And then the last thing I do is I recreated the turnover column by multiplying it by -1. And the reason I did this was just because when you see the heat map, all of our positives are going to be one color or a shade of that color, and all of our negatives are going to be a shade of a different color. And turnover is a negative value. But if you have high turnovers, when I compare you to the mean and standard deviation of your population, you'll have a very positive z-score. It'll say it's a very high number, in which case you'll be colored in the same direction as all the other positive values. So by multiplying by -1, I'm just flipping the sign and making sure that if you are a turnover machine, you are properly looked at as being negative.
So don't try to turn over things.
Yeah.
We'll catch you.
Exactly. There you go. Aaron Gordon, right? Okay. Cool. So there we have our new data set. I'm going to flip this data into a long data frame to kind of help me with the plotting purposes. So I use the melt function from reshape 2, and I say take the NBA main data set and the ID variables. Those are going to be the constant variables that we're going to use are going to be the player's name and their position. So right now it's sorted by the actual variable type. If you sorted it by, for example, Aaron Gordon, I think there's 7 or 8 variables that we used. you'll see all of Aaron Gordon's variables. Yep, so there it is. So player and position are our ID variables, so those are constantly repeated. And then I didn't even bother typing in, in reshape, in the melt function, you would normally type in measure.vars equal, and then I would have to type in field goal percentage, 3-point percentage. In this case, because I want all of the variables in my data frame, if I leave that empty, melt is smart enough to know to take player and position and then spin out all of those variables into a long format with each of their corresponding values in the furthest column. So now that we're ready for plotting here, there's a lot of players in this data set. So I didn't subset anybody out or based on minutes played or anything like that. So for plotting purposes, without getting too crazy, this week we've done a bunch of interactive ones. You could certainly go back and see those and turn this into an interactive Shiny app or something like that. I just wanted to do some random subsetting. Give me 8 players of each position group, and we're just going to plot those players across our facets. So I did it like this. I basically picked a set seed, so that would make sure that the outcome was reproducible if I ran it or Ellis ran it or any of y'all went onto our GitHub repository and downloaded the data and ran it. So I set the seed, and then I use a sample n of 8 players from each position group, and then I pull just the player. So pull is like select, except I'm only getting the variables in one column. So I'm basically saying that C sample, if you were to run that, is going to return to you a vector of just 8 player names, 8 random player names.
And the key difference between select and pull is that pull will return the vector of the column. Select will preserve it as a tibble.
Correct.
Or I guess as a data frame.
As a data frame, yeah. And the reason why we wanted to why I wanted to put this as a vector was because then I can filter on those player names when we go to do our plotting. So if we scroll down, there's a second way to obviously do this. That my way is a little more of the showing every single possible step for each position group. Ellis came in and also wrote a simple kind of function that you could utilize. So if you want to walk through what the function is doing that for the people.
Yeah, no problem. All right, So the way that Patrick was doing is a lot of copy and paste, right? Which works pretty well when you're just trying to quickly iterate through things. But there's potential for error. Like he could have written that, and he would have gotten no characters for SG. So my proposal was, why don't we, functionalize this? Let's use functional programming to do this. And so we know that we want to get everything by the position. So let's just group by position. Let's cut that up. And then let's write a function for us to be able to identify the players that we want to be keeping. And so I'm still following the same sort of idea that he's trying to do, where he's only trying to keep the top n or sample n players. But instead, I'm using a function to be able to identify that. So I wrote this function that takes a vector of player. So that'll be every single player that exists in that smaller subset of by position. I'm able to identify the number that I want to be keeping here. So that should actually be n right there. Going through it, we explain our own code and we find bugs. All right, and then seed there. So that is for setting the random number generator. So doing the same sort of thing that Patrick was talking about, being able to make sure that we're consistently grabbing the same players, or the same quote random players, because we've set a seed that's not going to be as random.
Pseudo random players.
Exactly. So then I run this, and what this does is it returns a vector of true or false. So it'll take a sample of n players, and it'll go, all right, which ones are unique? So which ones, so first it'll do unique there to only subset on, to keep a vector of the unique players. Then it'll sample 8 of them, and then it'll see, okay, of that vector player that I fed into it, which one of them exist in this new sampled subset vector there. And it's just a simpler way to do it. It'll hopefully prevent you from finding potential issues that you typoed up here. So subset players, and then we're going to do the same sort of thing where we're going to only keep the players that we've subset, only keeping 8 from each position group.
Yeah. There we go.
There you go. So it ends up with the same sort of stuff. Additionally, you could potentially have a player that played in multiple position groups and therefore got called on multiple times across multiple.
It happens, like Kyle Korver is a guy that comes up in multiple. Oh, Jimmy Butler's another one. Yeah, there's a few players that come up in multiple positional groups.
And so, in theory, this will protect you from accidentally doing that. If you do it on purpose, that's perfectly fine. Yeah. But this would, in theory, protect you from accidentally doing that. All right.
Yep.
So.
Okay. All right, so now we're into visualizing our heat map. So we'll do all of the steps there at the top. In kind of the beauty of Tidyverse is that we can handle all of these steps with the pipe operators. So basically doing our group by, using the keep player function, finding our players, then ungrouping, filtering out those players only, and going straight into, with a pipe, straight into our ggplot, where we set our X variable to be the variable, which is going to be 3-point percentage, turnovers, those types of things, and our Y variable to be the player. And then we put our geom tile in, just like in Danielle's plot. And we put our geom tile in, we fill it by the value, we color it by white, which is going to be the color of the lines between each of the boxes within the heat map. You could obviously leave this blank if you wanted. It would just have the color, or the boxes all touching each other. Geom text is actually, I put in the actual z-score value. We could have done other stuff, like we could have retained the actual values. So sometimes if you're, for example, handing this off to a decision maker, z-scores can be challenging to interpret. They might have their idea. Let's say we're dealing with a basketball coach or a general manager or a scout. They might have an idea of what kind of shooting percentage, for example, they like to see in their point guards. We could have retained the original values in our data set, and then we could have actually put those into the boxes. I just put the z-scores in to keep it simple, to show how the colors interact with the z-scores. Scale fill gradient, we use a low is blue and a high is red. Ellis, why don't you talk about the reason why we picked that scale color?
Yeah, sure, no problem. So normally a lot of the time when you'll be seeing a heat map or something along those lines, you'll see this. So scale fill gradient, low equals red, high equals green, something along those lines. But one thing that at least my group tries to focus on where I work is making sure that everybody's able to read and understand these plots. And the most common type of color blindness is actually red-green color blindness. So they would not be able to discern the difference between the high and the low values. So then this plot here has no value to them. They can't see the difference. So what I like to do, and I'm not saying that I'm perfect at this by any means, but is to try to pick color blind friendly color scales. So that means that anybody, no matter what type of colorblind they are, in theory can hopefully identify the difference between the two and go from there. There's actually a lot of packages and a lot of online tools that exist for helping you picking colorblind friendly palettes. Color Brewer, I believe, has a number of colorblind friendly color palettes that I would suggest looking at. If you want to learn more about that, or just go online. There's a lot of theory into what type of colors you should be using. Also picking color scales that are important, or color scales that highlight important values. So say you maybe don't want to highlight the tail end, so you don't want to highlight the high low necessarily. You want to highlight more of the mid-range values. Then you might use a different type of color scale where it's gonna go across a different type of coloring that highlights that. So when you're picking your colors, it's really important to think about, what am I trying to highlight with this? Because Klaus Wilkes, I believe his name is, has written a number of books on that. He wrote the cow plot package, and he has a lot of opinions on using color. Color can totally change a plot.
Yeah, it's a really important. It's a very important attribute when you're trying to tell stories with data through data visualization. And this is a very serious thing. We actually did have a situation where my group, we were presenting to some decision makers, and we had given a presentation like 3 weeks in a row, and one of the decision makers was like, hang on, I got to stop you guys. You're telling me that there's green and red dots on this chart. And we're like, yeah. And he's like, man, you guys have been giving me this presentation for 3 weeks, and I'm colorblind. We're like, oh, wow. It would have been great if we knew that from the start. So it is a really serious thing. To the point of knowing what to color or highlighting important values with color, we do use the scale fill gradient 2 function here, which is different than scale fill gradient. The gradient 2 function will give us a basically white or neutral value in the middle, where, for example, it would be a z-score of a 0, meaning that this person is equivalent or equal to the population in their observed value. Yeah,
exactly. So this just has a lot of power there. That if you're trying to make it clear that two values are different, they're diverging, this is the scaling to be using. So. Yeah. Sorry, we jumped on that high horse for a little bit there.
But it's an important thing. Yeah, an important one. And that so in Danielle's plot, she used Facet Grid to get sort of an X and a Y axis, so to speak, for her grouping variables. I actually used Facet Wrap here because I only have one grouping variable of interest, which is position, and this is going to create each a little box for each of the position groups. And I set my scale equal to free equal to y. So in this case, our y variable was player. If there was, for example, an empty value or something like that, it would effectively be removed from that scale from the y-axis for scale free y. Okay, the theme function here is basically a bunch of our kind of aesthetics to make it look pretty. We've talked a lot about this stuff in previous podcasts. I set the actual boxes of the facet titles to be black. I set the text within that strip of the box to be white and bold. So all of that stuff we've talked at a ton. We put the legend position on the bottom to save some space rather than putting it at the right and kind of scrunching up the figures. And then the labels, obviously a label that describes what we've got. We don't need an X or a Y axis label here because they are kind of intuitive. You see player and you see the variables from the NBA season. And then a caption there just to kind of reference our data source. So we can drag this out or hit zoom maybe. Yeah, so if we zoom in, we'll pop it out. And there we go. So, and you can change the size of those numbers obviously within the boxes. But now it is really easy to see. So if you look down at the scale, again, 0 because of that scale gradient fill 2 function is now white, so effectively neutral. And then we can look across there. So, for example, blocks in the center group, we see 2.5. Brooke Lopez's 2.5 standard deviations greater than the mean for the centers in the 2019 season. This is not scaled per minute, so I did write that up at the title. We could have scaled these per minute, or in basketball, you put them as like a per 48 or something like that. That would effectively remove some of the maybe no-name players who have really high field goal percentages because they took 3 shots and scored all 3 of them or something kind of crazy like that. But just a quick way to use facet wraps and heat maps in order to tell a story with your data and hopefully present it in a different or unique way.
All right. Well, thank you all for joining us today for explaining some Tidy Tuesday code and how to use facets and heat maps. So if you have any questions, please feel free to reach out to us at tidy.explained@gmail.com. In the meantime, this is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And Patrick Ward, and you can find me on Twitter at OSP Patrick.
All right. Thank you, and continue to explore your world.